Welcome everybody to this webinar on PowerPad, MasterSeries PowerPad. My name's Tommy White and I head up the sales team here in MasterSeries. I've been doing it for quite a while, and what I'm going to do first of all is going to take you through a wee PowerPoint presentation to explain to you what PowerPad is. So here we go. And we're going to have a little PowerPoint presentation, nice little introduction. And basically the MasterSeries is a massive range of software. We can do analysis of frames, portals, simple beams. We can do wind analysis, BIM integration, finite elements dynamics, and even seismic analysis on those. We then have this integrated design for designing steel, concrete, composite connections and timber. And finally we have some standalone programs, specialist programs for doing masonry and retaining walls. In fact, PileCap does integrate with the frame analysis, as does the office tools and the MasterRC, but they're handled also standalone, so they're in both camps. So to simplify the MasterSeries, we created three different ranges. We have the big building design suite for your large multi-story frames, and then we have this PowerPad Plus, the essential structural analysis and design suite for small building projects. We also have portals, and for those who don't come into any of those categories, you can mix and match your products that you need from our custom suite. And now we look at the PowerPad Plus. PowerPad Plus, we have analysis of frames, portals, beams, and wind analysis. We can do integrated steel, concrete, connection, and timber design. We can also do standalone masonry, retaining walls, pile caps, and composite. So the composite is only available in the standalone mode rather than the integrated mode. And all of this is in one bundled package. What you have to understand is that we're not giving you little simple pro formas, we're giving you real programs to do the work. And we're giving you versions of our full versions of the software. We're giving you a limited version of retaining walls. We're giving you the connections with some limitations. And we'll see those as we work through. So that is PowerPad. If you wanted to take it in a different tact, PowerPad gives you 100 member frames in steel, concrete, timber. You can also go for a 500 member version if you want. You then have your connections, your composite standalone, your simple beam designers, and your office tools. So this is all part of the PowerPad system. So let's go ahead and start the MasterSeries. MasterSeries 2019 from the 17th of October. MasterSeries programs, we have our frame, our portal, our connections, our slabs, retaining walls, and everything. What we don't have is PowerPad. And the reason for that is that in essence, PowerPad does not exist. PowerPad is your frame analysis, but 100 members. PowerPad is your masonry, but limited in the number of features. PowerPad is your columns and pad foundations. It is your connections. It is your portals. So if I wanted to know what I had, I would go to your license and I would see I have full PowerPad Plus with 100 member frames. I have 15 member portals. I have 100 member steel and concrete frames. I have some printing limitations on my connections, and I then have some limited access to masonry retaining walls, 100 member timber, and some limited pile caps. So it's the real program, not little simple spreadsheet pro formas. So let's get back to the programs, and the core program for all of this is MasterFrame. MasterFrame allows us to do our analysis. It allows us to pull in our wind analysis. It allows us to do our steel, concrete, timber design. it allows us to do our connections. So let's look at MasterFrame. And I am going to take a brand new file. But before I do that, what I'm going to do is I'm going to look at some of these frames. So simple beams, there you go, simple beams. Timber purlins, A-frames, attic extension, a nice timber truss, another truss, simple concrete ground beams, and in fact even those ground beams can be done with full two-way spanning area loading onto them for more power. A steel and concrete frame, a simple concrete frame, and then we're getting into more 3D concrete frames, and this is one we're going to come to and look at shortly, but I'm just giving you an idea of the types of buildings and structures that we can do inside the PowerPad. And yes, we can do reasonable frames and do the wind analysis on those. So what I'm going to first of all do is I'm going to take a brand new file. I'm going to call it Demo PowerPad Plus 101 and create new. So now I can choose how I want to set it out. I could choose a simple multi-story frame, or I could draw from SnapGrid portal frames. What I'm going to do is I'm going to choose a multi-story frame initially and just put that on the front view. So 5 bays, 3 stories. I'm going to accept all of that. I'm not going to go through this in great detail because I want to just show you over this hour a flavor of all of the different parts of the PowerPad system. Here we have our frame, and we'll just close that. All done. Front view. And we'll just turn off the color of a section. What I'm going to do first of all is I'm going to delete a few members. So modify and delete. And I'm going to delete these members and say apply. And I'm going to delete that member and that member and that member and say apply, and maybe take those two out. So what I can now do is I can put new members in. So create, I can easily add in beams, so I can say let's add in a beam, and we're going to choose one of the existing ones, a 457. I will choose that down to a 406, and I'm going to come off here at 10 degrees. And I'm going to do the same in the opposite direction at 10 degrees. And what I can do is I can then snap onto this at distances along the member. So I could snap along. But in my case, a little cheat would be to escape from that. Take this member, draw a member up perpendicular, then draw my member in, and then take this one out by drawing it. And likewise, I can take this one out by drawing it, and I've now got a nice little portalized frame. So you can see we can specify angles, and that's all set up in the settings, how we define things. We can also snap along members, so if I wanted to say I wanted on this to draw another member here, I wanted to make it a square hollow section of probably a bit smaller than that, a 70 by 70 square hollow section by 5, and I wanted to make that 1.2 high. I've got 1.2 if because I'm snapping it every 100 millimeters, which is the setting at the minute. Or I can type in 1.255, enter, and there I have, and then we come. So you can see we can have members. If I want to take this, I can connect to the intersection of that, or I could come down to the point load. So I can take that to there and then connect this one back up again. So full remit of generation tools. We can quickly apply things like vertical bracing. So if I was to say let's go for X bracing, let's go for flats, I can very easily say let's go for a 150 by 10 flat, which is tension only. It's a bracing member, and all I need to do is say it's going from here to here. In fact, I should have done it the other way around, so it goes to the higher member, and it doesn't like the sloping, but that's quite easy to put that in. I can just go in and say add members, and the same is already there, bracing. It was just saving me a little bit of effort to put those in, and there it is. If you wanted to take those and move that to the next bay, we can either redefine it or we can shift it. We could say create, and we could say modify, so we're changing, and say move, and we're not moving the ends, moving whole members, that member and that member, and we're going to move them. And the nice thing is we can actually say here how you want to move it. You want to move it from this point to that point, apply, and it's done. You have all these fantastic tools to play with. You also have all your properties of materials. We saw the basic definition of steel. Some of the members were already defined. We can turn around and say, well, actually I want that to be a double haunched member, and I want it to have a 1.5 meter haunch and a 0.75, both the haunched areas to be twice the root, and there we get our section defined out of the 457 that we chose as our initial section size. We can also take members and put holes in them. So I have to take one of these members, make it a steel member, and make it a 406. I could go for some cellular form beams, which means that the beam becomes a bit deeper. It jumps from the 406 up to 509 deep as being the standard castellation, and we're going to go for, I prefer the openings 1.35 spacing in that cell form beam. We can also take another beam, and we could say, well, actually we don't want to use a beam, we want to use a built up section. So we're able to say that we actually want a section that is 500 exactly deep, with 200 flanges, 15 mil thick, and a 10 mil web, and that then is going to use that built up plate girder section. If we don't want plate girders, we don't have to use them, but if we don't want cell form, we can go for what we call isolated distinct openings. We can add in distance to opening. I'm going to say 1.25 meters. Opening diameter, I'm going to say 200 because that's in millimeters. And offset, I'm going to say no, it's centered. So there we go. There's my opening in the beam. Back into that editor, and I can say repeat twice at 1 meter centers. And now I've got 3 more of them. I have full flexibility, so I have my steel sections, my built-up sections, my haunch sections. I can even, for these columns, I could put in a steel section, make it a UC, very simply, a UC. No, we don't want any openings on this section. Come down to 203, and then I can say I want to put another section into the web of that, and I can apply that, and I'm going to take out those and say okay. I accidentally put them in at the same time, so I can put in another section that is a plate, or in my case a secondary section, and I think possibly the 116 is a wee bit on the big side. I could put a small section coming in to the side of the other section. Obviously that would normally be the other way around, but in this case that's all I'm doing. So all very simple and straightforward. What I want to do now is to jump through and look at a detailed frame. So I'm going to open a frame I had up, and I've generated this. I could even pull it in as a DXF file if I wanted to. So what have I got? I've got some steel sections. I have put some openings in the in the members just for the fun of it. It is all steel work. I have got haunched members. Now, if we turn off the 3D and turn off the colouring, back to wireframe, we'll see that these are continuous members because they're real physical members, and then these are stopping and starting. Likewise, up at the roof here, we have this member coming across to pick up this fancy little opening, or not opening, valley that we're creating in here. Hard to see with all the bracing, but if you turn it around, you'll see that we do have this. And we have put all the sections on, but what we've also then done is we've gone and we've applied area loading to this. So we, with our PowerPad software, we can apply area loading, and as you can see, this isn't a square frame. This is quite a skew-width frame just for the fun of it, and we've even got little projections on the walls out here for whatever reason, other than I felt like it would be fun to do them. We're spanning left to right here, and if we look at this panel, we're spanning the opposite direction. Now at the minute they all have the same intensity, which is the default. I could take this one and I could say, well, actually I want the live load to be 6 kilonewtons, so it's now a heavier intensity, and we will see then the different intensities here and on the roof. And if we asked for the key, we will get all the different values, the 1.5s and 4, and the 1.5 and 6 for that blue area. And then I'm taking a tiled roof, so 1.5 for concrete tiles and 0.75 for my snow loading. And that's all done automatically and very easy. It is a very, very powerful system. The other thing that we've done is, as well as the gravity, we've put on patch loads. We've put on patch loads, and if I just come back in to the editor, I think it's the easiest place to find this, and go to line loads. So if I come back to turn this all off, we will see now we've got our patch loads. We've got a perimeter patch load, and then we've got a couple of individual patch loads as well around the edge of this staircase, including a heavy load here for the actual stair coming up onto the wall. And there's both dead and live components. There's dead on this one, but on this one around here you'll see that we have both dead and live components, a 12 kilonewton dead and an 8 kilonewton live, so 4 times 2 meters of run to play conservative, and we're taking onto this as this access load. Possibly we should take that load there and put a return on it back in, so I could go and say at the minute it is on member, I am going to take another load and I'm going to say it is just draw, and I'm going to say that the first load is 7 kilonewtons from a small wall, and I'm then going to draw it from there over to there, and it should then apply that load onto that wall. What have I not included? I'm on the wrong level. I need to tell it what level I'm on. I'm on level 1, and there we see the wall, because we could have been on different levels, and obviously it makes sense to tell it which levels. And if we had multiple levels, we could repeat that on several levels at the same time if we're in a multi-story arrangement. So that's your basic loading from a dead and live load scenario. If we look at the wind analysis, we can see that we can come along, we can tell it that we're going to do this as a wind loads on 4 directions, We could slip a fifth one in if we wanted to for one of the unusual angles, but the 45-degree catchment will probably cover that anyway, so I'll just stay with the 4. If we then come and look at the wind panels, we will see that just like in the area gravity loading, we're able to define different panels to catch the wind load, and it all makes sense. And the nice thing is that this is very easy to do in the system. It's all automatic. I can just go dump all that, say yes, and then just say auto everything. And that's correct, that's correct, that's correct. Everything's all correct. And that's even knowing that those should span that direction. What I am going to do is I'm going to tell it that this actually panel here I want to edit, and I want to take this out of that panel, and I then want to add another one in, and it's going to be spanning, two-way spanning in here, because in here I'm going to have masonry rather than just sheeting for whatever reason, and I'm going to tell it to combine with this panel so it knows how to handle that. So that's the panels done. All I need to do then in the wind loading is go wind site data, and either a GB or an Irish site, and I can either put in the national grid reference or pick where it's at. At the minute I'm around Darlington, NZ, and I can go and place that there. In 2020 we will be moving our wind analysis over to a slightly more accurate wind analysis, which will allow you to automatically put in postcodes. At the minute, if you need a postcode, the best thing to do is just go to Grid Reference Finder, type in the postcode, and it will give you the 6-digit plus 2-letter grid reference automatically. So there's my loading, there's my frame automatically assessed. All my loads, member loading cases, I have automatically created quite a lot of cases, and that's all to do with all the different wind directions, the W1 direction, the pressure, the suction on each direction with the different permutations. And these were all automatically created for us. We don't need to generate it all, we just say what all we want, and we don't need dead load only, and then we just say replace everything, and then I have 88 loading cases working to the Euro code. In my case, I could have chosen the BS or even the South African code of practice, but in my case it's all automatic. So now what I want to do is just analyze. Okay, so we've got a notional horizontal load on everything but the service loading cases, and it's a 100 member frame. 88 loading cases just been done in under 12 seconds. And here we go into our results. First things first, check out the graphical results. I always look at the deflections first, not magnified, but at something like 1:1 with, say, the main frame, and if I can say yes, I'm getting no crazy movements, I know I've got a stable frame. And I can even augment that onto all of the ultimate cases just to make sure that I don't end up with any crazy movement. And that tells me that the frame is stable. If I went back to bending moments and say let's look at the first one, as you can see the big moments are coming in those clear spans, which we may have fun sizing up. We are getting minor axis moments due to the three-dimensional aspect of the frame and the fact that some members have major and minor axis thrusts and pushes. So that's your ultimate. Let's look at the envelope of ultimate, and we'll see that very little changes here. Obviously it's all to do with the wind loading, so I can then say let's just magnify this up a wee bit and we'll see how the wind is pushing and pulling the frame about, and it's all straightforward. Now we can go into design, very straightforward again. seamless, and we can choose a member. And a couple of interesting things have happened. I'm actually not looking at one member but 6 at a time. I'm not looking at one member, I'm looking at 12 or 20. I'm looking at 6 and 6 is 12 column portions. And the reason behind that is because with the PowerPad system, we're able to define design groups. We're able to say, take those 6 members, which are all nice, simple-ish portal frame rafters. We'll call it Port Raft 1, and we will design them all the same. We will design them for purlins at 1800 centers, and we'll keep them all the same section size. So if we look at our columns, we'll see the outer columns are all sized to be the same. If we look at our inner columns, they're all sized and grouped to be the same. Bracing is all going to be the same, including over here. We could have probably pulled that back to there and there, but I put it in as being bracing horizontally there because the roof is going to be braced from this hip end and everything else. You're asking where's the bracing in this direction? Well, this answer to that is in fact that we actually put some horizontal supports because we were going to assume masonry in this direction but not in the other direction. So we just put some horizontal restraints to consider the restraint of the masonry. So we haven't done everything, but we've gone and done our big hips and our wee hips. And if I wanted to, I could make these 2 beams here the same. So I'm going to create another group called trans, and I'm going to select that member and that member, and I'm going to make them whole and whole, and I'm going to make them restrained by other members, so they'll automatically work out their restraint distances. So that's how quickly it is useful to do groups. And I'm now just going to go back into my steel design, and because I didn't change anything fundamentally, it's happy to work with what I had. So if I now look at this beam that's got the point loads on it from this jack rafter, then you'll see that we're looking not just at the bottom but at the top and bottom beams. And we could get away with possibly something a bit smaller. A 15289 is not working other than deflections. We'll come to deflections in a minute. I would prefer to see the 203 133 23. Or if I want to keep it small, I might decide to go in and use the UC at 152. And it is just a deflection problem. So inertia is the problem, so we probably would be better just to move back to the UB slightly deeper and take the 200 deep on that. And of course we don't have to do those choices all ourselves. The software, like all good software, is fully automated. We can just hit the automatic and it's giving me the shallowest beam. If I turn on weight order and hit automatic, it's giving me a slightly deeper beam that's going to work. But in my case, no, I prefer the slightly heavier squatter member. So that's how easy it is to design. And if we look at our columns, our main portalized columns, we can see the upper portions are all looking good until we come to say this one, and everything looks to be okay. If I look at my rafters, they all look to be, well, they were looking okay out here, but with this big point load coming through from the jacking rafter, we're just outside and we're less than 0.2%. So we could argue that we just accept that, or we could increase our haunch length from 1 to 1.1 meters and therefore make it work. Or if we wanted to stay with that, we could tighten up the purlins, because we really have a bit of play here. We could turn around and say, well, actually, let's make the first one not 1800, but make it 1600, and then make the rest 1800. .8, and we'll see then that we're showing that that's all okay. And that's half the battle. The other half obviously is then your Appendix G, and that's the really complicated system. So let's double click again. We can see that over its full length out to the point of counterflexure, it would not be happy. So we know that we're going to need to stay at the 1.6. Yeah, 1.6. So we're going to say no, the portion is going to be, in fact, it's going to be not 3.6 but 3.4 overall. And would that work? No, it won't. So we're going to have to start at 1.6, put a stay in, and then stay out to the 3.6. So we're just looking after the portions and seeing that it's all okay. So we now know we need this stay here at the 1.6 meters out on our rafter. Now, if I go to frame views, it's very useful to have a look at the floor plan, and we can see our beams that aren't working. So I'm going to quickly run through and ask it to size these up. So that one's sized, so auto size all visible members, and it's going to try and resize all of these to actually work. So they work. And if I then reanalyze with those new sections, what I can then do is scan these for failures, and hopefully I should get no failures, and all clear. So I can now say, just give me all the unity values. So I can see the unity values for all of these members, and I can just print that out as part of my report. It's very, very useful, and I can do that for each of the levels. I can then move back up to, right, what I'm going to do instead, I should have really created a view, but not to worry. Put this in the front view, and then just go and window from here to here. I could give it a view name if I wanted to, put it in the plan, and then we will see what are the unity values. And there is no unity because we never scan for failures in these. Scanning these members for failures, and just like the others, we can then see these very simply output. So we've got 7 members failing because we never designed all of the members. And what are they? Well, let's have a look. These members out here are failing. If I go and look at only the failing ones, we could come in and fix all those. So what I could do is resize those and go through, reanalyze, rescan, and check out again. Bear in mind that we can actually do this quite efficiently in the 3D mode as well. And just doing that a second time. Quick rescan in go, and yes, rescanning. So here we go. We just need to do a wee bit of a hand holding. So that's with 1%. So we just need to fix those, and that's not significant in fact, because it doesn't actually count as a member in reality because it's a masonry wall in there. So that's why it's just getting ignored. So that's how we can report and do our design. So we've just in fact covered 3 parts of the PowerPad. We've covered analysis, we covered steel design, and we covered wind. We're very, very quickly going to go in and do some connection design. So let's go back in now from scratch, design, steel connections, basic information. Yeah, we'll just do an eaves type connection, 355, and it's asking me where. I'm going to click here and I'm going to get this, and it looks to be okay except for two things. One, it's saying that this may be a problem for fixing, and I can understand why. That may present itself as a problem. So a couple of things we can do here. We could take the bolts and place them in from the other side, which makes life easier, and that's the wee cheat option. So under options, I can turn around and say no, we want to draw the nut on the end plate side. So apply, and therefore we don't have the clearance problem coming through. We'll see 6 mils and 8 mils all automatically. And if I scan that, we'll check all the loading cases, and you can see here the loading cases are all coming through, and we'll find that the joint works for that. Now we could apply that to here and just confirm that that works. We could apply that to here and confirm that one works, and it does. And we'll just do a quick scan. Now, one of the things I could have done was to merge all those into being the same connection, using the same grouping technology that we did previously. So as we can see, quite straightforward and simple. I want to add another joint in. I want to add in a base plate, and I want to put the base plate down here where I've got quite a heavy load. We'll see we have a bit of a compression problem at the moment, so we sort of need more area of pad, and so all we're going to do is go to the base plate, and it's a 350. I'm going to make it 400, and I'm going to make that breadth to 250. So we're nearly there. We just need to look at our concrete grades, and cube strength I'm going to make 30 Newton, and it's now happy with the more heavier 30 Newton cube strength. Obviously that is then converted into Euro code cylinder strength for you, and you'll see that the joint is working now. The thickness is the default thickness. I'm going to suggest that we actually reduce that down to 15 mil, and it hasn't had a problem on the joint. So that's our joint. And again, let's just run through that, making sure there's no oddball pullouts that are causing us a problem. And that's my joint designed. And I want to just check a bracing joint. So I want to finally add in a bracing, which is vertical bracing onto a column. And I'm going to choose this one here, and it's found the two beams. What I want to now look at is, in the same model we can also design the concrete pad foundations. So we're going to go for C3240. Safe working pressure is going to be 200. We're going to go for no cohesion, and we're going to have a distance of submersion of about 0.5 of a meter. No passive, and we ignore service moments and just say OK. Off it goes, and it's trying to now size the pad foundations, and it's giving us, for example here, it's saying that a 1650 by 450 pad is going to work pretty good. We're up to 170 on our 200 bearing stress. So would we get away with a 500, or sorry, 1500? We possibly would. So 15 is giving us an ever so slight problem with our combined, and we could possibly get around that by making it heavier, and that's not actually helping. So we would need to make this slightly bigger. So let's go 16 by 15. And there we go, that's your pad foundations design. So all integrated into the one system. Now, let's come out of MasterFrame, and we can also look at doing simple portals. So we can do simple portal. I'm going to take a new portal. Portal 2. And I can do what they call elastoplastic design of portal frames. And I'm going to use 2 spans, and I'm not going to make the span symmetrical so that I can make them a 30 and a 20 meter portal. Put that in front view for you. And I'm going to make them a 7-degree slopes, and it's going to have that, and it's going to have 2 meter haunch on the other side, so 3 in this side, 2 in that side, because it's actually meant to be 20, not 29. That looks better. And what we can even do is when we come to the columns, we can turn around and say that this is the middle column is 7 minus 1, and then this one is 6, and that drops everything down by a meter. And off we go. So we have full access to elastoplastic portal design of simple portals. We also have a multitude of other simple programs available in the program, such as Masonry Panels. So there's no reason why we can't go in and do a new masonry panel. Here we go, a simple masonry panel, 2 walls. We're going to go for lateral load of 1.1. So at the minute we're now failing, as we can see with our simple support and our fixed bottom. Now we probably want to make the bottom simply supported but the 2 sides fixed, and that will make that work. If we had to go fixed and pinned, then we are with a 20% overstressing. What we're able to do there is to think about materials. So let's look at the inner leaf material, concrete block, and changing the strength of the blocks above 17 doesn't really have much effect on the system. If I go to the outer leaf and we go for clay brick, instead of being over 12, 7.5, that's helped ever so slightly. We're down to 4%, and if I say no, it's under 7%, then proper good clay bricks will work without having extra work on it. We're also able to apply not just lateral load, but we can also apply a vertical load. So we can take, for example, the inner leaf loading, and we can say that we actually have a little roof here that's going to give us a 10 kilonewton axial and a 5 kilonewton, sorry, that's dead and live, and it's now going to improve or alter our factors of safety according to the weights of the line loads on the wall, and that may have also made us work as well. So we have simple panel design. We can also obviously do freestanding walls or piered single leaf, possibly not 3 meters high, make it 1.5 meters high piers. 440s by 215s will work, but obviously that's because it's not free in the top. So let's just go for freestanding, and now we are in a wee bit of a problem. As you'd expect, 100mm leaves do not work on these sorts of walls, so we would need to play around and increase that considerably, and obviously you wouldn't have the lateral load on the the wall loads on the top, hopefully on a freestanding wall, which actually makes it worse, and you'd need to thicken that all out. So very flexible little program for masonry, just as flexible is your retaining walls. This is all inside the PowerPad system. And if I just go new, Tommy, and we'll see our default wall, I'm going to say that it is 2.5 meters high. It's going to have a maximum of, let me see, 500 toe. The heel then we'll decide it will be, I think 250 is a better size for this, and we're going to make the thickness of the wall 250. So first things first, we'll accept the 500 mil water pressure because we're rushing under pressure here to get things done. What I want to look at is how short can the heel be until it starts to slide. So we're here starting to slide, and there it's working. So 215, I'm going to make it another 100 to make it 2250 overall. So now the wall stability is fine. All I need now to look at is the inner face and the top face. So let's go for reinforcement, and we'll see the inners. If I make them 12, they're now fine. The bottom steel, I could again make them 12, and that's now fine and all done. Now we also can play around with things like the slope. We can put a sloping back onto the wall, and obviously that does again cause you problems with your sliding, which makes everything have to go a bit longer. If it was in some sort of basement or something, we can argue about a prop. Because we're in the PowerPad, the only prop we can do is a prop at base, which means we have no problem with sliding. So we can reduce this way down and then just satisfy it for overturning and pressure. So there we go, it is propped somehow with some joint or something, and off you go. So retaining walls, a very straightforward program that's part of the PowerPad suite. We also then get simple beam designers for steel concrete. We have composite and we have timber. The timber can integrate into the steel just like the pads and everything. The steel beam designers are very straightforward, but the concrete beam designer is the same but better. So I'm going to go new, put a file name in, put a second span of 4 meters and a third span of 1.2. Tell it that that third span is going to be a cantilever by saying last span cantilever. So that's now got no reaction out here. Let's look at my loads. 10 and 32 throughout, and it's a rectangular 800 wide by 350 deep. That's a bit big on a 5/6. Let's go for 500, and we'll see that again, you can see the alternate loading patterns already done, and it is for some reason thinking it's in the BS. I'm going to tell it that it's in the Euro code, and it uses the more onerous live load patterns. And we can then just go in and design our concrete. I'm just going to say OK, and here we go with our reinforcement 425s. It was 500 wide with 350 deep. We were keeping it quite narrow. It's a wee bit unhappy about this bar being unrestrained. In essence, I might actually just nip back and make that breadth into 400 by 350 deep. See what we get, and then tell it that we only have one leg. We'll see that most things are working. There is a blue here, and it's probably to do with lap lengths. Yes, the lap link pitch, so we just need to tighten my links up, and rather than just tighten them in around the laps, I'm going to reduce them everywhere down to 200. So there seems to be another problem, and here we go, and it's really to do with the transverse centers. It is actually still demanding another bar. So 4 would do it. Or we go for 3 bars and then go for a 3-bar arrangement in the steel. But we've this full play around in our steel, and in fact I never even designed it, I just assumed. So now it's failing, and yes, the 425s are required. Would 325s have worked? Possibly, with a wee bit of redistribution, which is something we can do, but I'm just going to leave that as it is. And again, 425s is not going to work, so I'm going to put that up. Sorry, 420s. 425s is going to work. I could take that and again split that if I want to try and be economic, by splitting it into 2 sets and then reduce one pair down to 20s and 25s, and likewise down here, but they're quite close, so possibly not. And it's a very straightforward and simple concrete beam program available to you. So that's your concrete beams. Steel is similar. Composite is a wee bit more specialized, and in the composite, we'll just do a PowerPad beam, is very simply either a secondary beam, in this case 9 meters with a 3.5 and a 3 meter spans approximately. I can see the steel stress is 2% overstressed, so we want to look, what are we using deck wise? I'm going to go for multi-deck 60. I'm going to go for a 150 slab, that's good. And then I'm just going to say auto size it and see what we come up with, and we're finding for this a 406, 178, 67 is the shallowest beam that will work with 2 studs per trough. If I was to go to lightest, the 67 would become a 60 at a slightly different 2 per trough, but we're also using, somebody's been playing around, we've been using the lighter European grades. I'm going to resize that up, and I'll get a 406, 146, sorry, 140, 46, 1 per trough will work as the lightest section for that. And we can also do the same for our primary beams as well. So the composite, again, is another lovely little program that's included in the PowerPad suite. Timber we can do internally in frames, or we can just do standalone. So we could do standalone timber beams. No different to what we were looking at there a minute ago for the concrete and the steel. So little timber beam, 2-span beam, 100 by 300 deep. We actually can go for the design and tell it that we want to use a material that is C24, and it's actually now suggesting a 75 by 200 will actually work on this member. Maybe not, so I wasn't picking the right member. It was that one. And I'm going to say 300 by 300. We could go for a glue lam 30, a big strong member, but we're still suffering slightly in bearing and slightly in shear, so we probably need at least it to be 350. And now we just have a bearing problem, which is really a question of seat, setting out what the seat is for the design, and I haven't set out the bearing length. Bearing length 125 will make it 150, and everything works. So our simple continuous glue lam beams, and those can also be handled elsewhere inside MasterFrame, all part of the PowerPad system. So I'm just going to look at questions. I don't think there have been many questions, and see what has been asked. Somebody's asking about steel grades and aluminium grades. Well, certainly you can go in utilities to the open library. You can decide what steel or concrete grades you want to consider. You can consider say what types of sections you want to consider. So if I just go in here and say edit, it's going to take a new database, database 1, and I'm now going to be able to say I don't want the Americans or the Europeans, I just want the UBs, I don't want the cold formed sections, and I'm going to go for ang rather than angles because angle is an Anglo-Saxon, that's the UK, and we'll go for PFCs, and we will take out the 235 grade and we will set it 355 as the default, and we can save that. And in my case I've also removed a section size or two out of the lists. We can also go into the editing of the libraries and we can add in another grade, and in that grade we can give it a name, the thicknesses for the changeover and stresses, and the yield and ultimate stresses, and if it's not standard steel, what its Young's modulus is. So we can put in black iron, we can put in possibly even aluminium if you want. However, one must stipulate that the design is to the standard steel design code, not an aluminium code or anything like that. But certainly from an analysis point of view, that's not a problem. And likewise, it's where you can add in sections, where you can import sections. I don't know, have I imported the heavier UBs there? I think I have imported the heavier UCs. There they are, the brand new heavy UCs up to 1299 kilograms per meter, which is really the American W sections, and it's quite a hilarious thing when you think about it. It's a 356 serial size, but in essence it's 600 deep outside flange to outside flange. So it's a mile away from that, so don't get caught out thinking that these are only 350, 400 deep. They're not, they are enormous. And I'll just close that without saving anything, and I will return back to my default open library. Somebody's asking about a cloud license. The software is on-premise, not on cloud, and it's either on-premise as a USB key, which is what we've been using for the last 20 years, or you can get an on-premise using a soft lock. Now the soft lock does have the advantage of being able to check out and move about, but you still need some sort of network to move between share between computers. This is fantastic. Can I get a demo version? Absolutely. Very straightforward to get a demo version of the Master Series. If I just pull up a template product range and just go into PowerPad, and in there, once you're viewing PowerPad, you just say start your free trial, and you just put in your details, and you will then get a 14-day trial of the software. The only thing that's limited is printing of results. The other thing is that it will not run on a Mac, the soft lock, and it will not run on a Mac for that point of view. Can you do wind design for any part of Ireland? Absolutely, Stephen, that's not a problem. Just coming back, say yes, go into my my little frame that I was playing with earlier, into wind analysis. Very straightforward. Loads, wind, site data. Okay, if I change from UK to Ireland, I get an Ireland map, so I can choose a location and see what the basic wind speeds are. Quite significant. 27. Dublin is, I think, down in that little nook. Yep, Dublin's there, and you'll see it's only 24, whereas up out here you're up to 26, and if you go into the mountains in Donegal, you also are quite high. And we're in the sea now. So you can set those. You can also pick towns. We can pick some quite interesting towns. So if we go to Dingle, where the dolphins like to play, and it should be down, we are down there, we will see we're way up to 27 basic wind speed, and that's going to give you a southerly rather than southwesterly. Well, actually no, somebody's rotated the world around. There we go. South, it's west by southwest. Dominant wind is what you're getting there. Now you can also put in your Irish grid reference and get exactly where you're at, and that grid reference finder website also does the same thing for Irish references. So grid reference finder, here we come, scroll on down, click on the wee button that says Irish grid reference finder, and we can either say, right, we're over here, just outside Knocklong, and we're going to put our wee map just there, and we should be able to pin. There we are, and we go up and we just grab the long grid reference, and then we put that in. So Control C, back to the Master Series, take that and leave the I. Control V, take out the first two. Take out the first two because we're into the nearest 100 meters, and enter, and lo and behold, there's where my exact location, lock the site, and that's it, locked down. And I'll say that grid reference finder will also allow you to put in a grid reference such as BT38, which just so happens to be our offices, and it will then give you the map all the way up with us. Can you design RC ground beams more than 3 spans using MasterFrame rather than the simple beam designer? Absolutely. The concrete beam designer is, as you say, is limited to 3 span beams in the PowerPad version, but there's absolutely no reason why you can't go in and say, I want to take a new file and I want it to be a continuous beam, and I want it to be 12 spans, default 8, and put in some dead and live load, dead of 12, live of 4, and have it alternate and apply, and that's going to give you all your loading, and then you just move these about to get your exact spans, and it's no different once you've done that. Very straightforward. Does timber design include Flitch beams? I don't think Flitch beams are available in the PowerPad license. Having said that, the upgrade from the PowerPad version of timber to the full version is very light. It's not expensive, so that's beam designers. If I go into timber design, and there's nothing in there, and just take a new file and go for a flitched beam. Yes, I can do a flitched beam in here. What I can't do is do it externally linked to MasterFrame as you would in the full version. So yes, you do have it. Ladies and gentlemen, that's about it. I think I've covered all of the questions. It's been very, very useful. As I say, if you want a demo of the software, just go and request your demo. If you're already using the software and are wanting more guidance on how to do things, just go back to the front screen of the Master Series, go to Resources, you have Manuals, which gives you all the manuals, and most of them are pretty up to date these days. You also have tutorials, and they will be pretty up to date. So if you take, for example, the I'm trying to see my dates here. Yeah, Connections has been updated. The 3D frames been updated recently to cover all of the new stuff, and I think if somebody asked for them, there are Portal updated tutorials as well available. I just don't know why they aren't installed on my machine with the latest patch upload. I will see if I can get those pushed on to the next patch of the software for us. And those are all available to you, and they're very, very straightforward. You also then have the biggie, the videos. And the videos is basically taking you through into our user area, but giving you access to the videos. So getting started on connections. Here you go, there's your little 1, 2, 3 basic connections and how to do them. Very simple, short, sweet videos. Retaining walls, 1, 2, 3 lovely short videos. Things like 2D frames, well, you're going to have a simple beam, a little goal post, can't get simpler than that other than a simple beam, and then into a little plain frame steel design in 2D. In the 3D, you're then into this bigger 3D tutorial for doing it to steel and composite. So you have all of this available to you. You also have the more detailed videos, such as on dynamic and seismic and finite elements. I mean, for example, in the finite elements, there's a lovely video that was done recently on a semi-detached house raft, and it's very straightforward to do, and very, very powerful and quite enlightening, because you're talking about subgrade modulus of your raft and everything. So it is all available to do. So all of those tools are available to you, of course. So are we in the help desk and in the sales team. If you have any questions, just send them straight through to help@masterseries.com, and they will go either to myself or one of my colleagues in the tech support team to help you out as good and efficiently as possible. So ladies, gentlemen, thank you very, very much, and we will get a video of this up on the web in a few days time, and you'll be able to go back and review it and show it to your colleagues and everything. So thank you, enjoy your day, and we look forward to seeing you at our next webinar. Take care now.